Thanks for attending this session. First of all, a quick poll. Who is already familiar with the Android NDK, so the Android Native Development Kit? I can't see much with the light, actually. OK, maybe half people. Cool. So let's get started. Here's the agenda. Since not everyone in the room is knowledgeable about the Android NDK, I'll do a brief presentation of what it is. It's quite a complex topic, actually, but we'll go through it. Then I'll talk about the brief history of how the NDK was supported within the Android IDEs and what we can do with the Android Studio today with the NDK and how to migrate to a Gradle experimental plugin. Because you'll see a lot of what you do with the NDK is always a bit alpha, experimental, buggy, hard to use. And that's why I made this presentation. It's to save you weeks of crying in front of Android Studio because it's not working. So I did it for you. So the Android NDK, first of all, that's an official tool from Google. It has been existed from the early versions of Android. That's a toolkit that allows you to integrate C or C++ code and assembly into regular Android applications. So of course, you all know Android applications, usually it's mostly Java. The whole Android SDK is in Java. But you can have parts of your applications that are written in C and C++. Mostly it goes through having Java methods declared as native. So you don't go outside of the Java virtual machine or do anything fancy. But you declare part of your application as declared and written in C and C++. And your C and C++ code will be written against the NDK and the JVM. So you can have part of pure C and C++, but you always need some sort of wrapper in between your Java code and your C and C++ code. Let's explain it a bit better. So all the integration of C and C++ code works through the Java native interface. So the Java native interface isn't something new introduced with Android. It's something really old introduced with Java, and it has been there for quite some time. So the Java native interface is a system that defines how you should communicate between Java and C code. So on the Java side, it's mainly the existence of system.load library. So system.load library is a function you use to load a native binary, so a .so file, a shared object binary. That .so file contains the implementation you made in C and C++ under the binary form. And on the Java side, you also have a native keyword. So you add this native keyword to any functions inside your Java, and that will mean that the implementation of this function will be from one of these .so files you compiled. So you will not have the implementation inside the Java. It will be declared as native, and the JVM will look for the implementation inside .so file you will have loaded with load library. And on the C and C++ side, it's mainly the JNI.h include. So the JNI.h will give you Java primitive types, so on Java integer, Java double, Java objects, Java methods, Java classes, and so on. So you can manipulate and interact with these from your C and C++. And it's giving you two really important objects, JNI-env, that is the Java native interface environment. So that's the object that allows you to talk to the JVM, to ask the JVM to create objects and so on. And the Java VM, so the JVM. That allows you to just get a JNI environment, actually, mostly. So to map your C and C++ implementations and the Java implementations, you have several ways to do it. So first of all, you need to manipulate Java objects, so objects that the JVM can understand. So here is a prototype of a method on top. So you can see it's returning a JInt, which is an integer that Java will understand. And it receives GNI env, which is the GNI env you can ask to create Java objects for you, and so on, and access Java methods and execute them. And the current name of a class or object that's calling you, the reference to it. And the name of this method has to be specific if you want it to be automatically mapped to one of the functions you declared as native. So here's how you can do it. So start with Java, then the package name, then the class name, and then the method name of the one that has been declared as native. You can also do it manually using GNI env register natives. That's a bit outside of the scope of this talk. But that's to give you an overall picture of how the NDK is working. So I told you, you call system.load library on a .so file, so on a binary. And the NDK is here to help you to generate these binaries. So the good old method with the NDK is you download the NDK package from Google and you extract it somewhere, and inside it you have a script called NDK build. And you can call NDK build, and you can see here NDK build, and it will build from your sources the .so files. Then they are generated inside libs, inside your project, and then they are integrated inside your APK under the lib folder. And since Android is supporting many different architectures, 7 today, there is one different .so file per ABI. So you can find ARMY ABI v7a, which is the most common one. You can also find x86 or x86 64-bit. And all these are different binaries for your same source code. And system.load library will load only one that is compatible with our architecture, and this one will have been installed on your device. So when you execute an Android application that is using the NDK, you first, at runtime, so you call system.load library, usually in a static block of a class, so it's called at the right time. So it will, at this time, map your implementations to the methods that will have been declared native. And then later, when your code is executing still, as soon as the Java method that has been declared native is encountered, the C and C++ implementation is simply executed. So in the same context, there is no change. No new thread that is instantiated or so on. There is one exception to this classic model, is when you use a native activity. So a native activity allows you to develop an Android application without even touching Java code. But even if you use a native activity, you will have to deal with the Android SDK, which is almost fully Java. So that means you will have to call methods, etc., from your C and C++, call Java methods from your C and C++. The only difference when you use native activity is that the system will create himself an activity, load a .so file, and then it will execute your Android main from your .so file. So yeah, I know it was a bit maybe short overview of the NDK. It has been required to know how it's supposed to work and how you're supposed to use it. So you have the NDK build part that is building your sources into .so files. And you have a part that integrates these .so files into your APK. So later when it's installed, your .so file can be loaded. So that was with the Gradle method. So you call NDK builds, they are placed inside libs, and the .so files are integrated inside your APK when using Ant. But we're in 2015, so it's the year of Gradle, Android Studio. So where are we now? First of all, there was already some sort of support for the NDK inside Gradle and Android Studio. Back in December 2013 now, there was already some sort of support. So this support was calling NDK build itself with auto-generated make files. So you only have to give away your, to declare your sources inside your project, inside the JNI folder, and everything was taken care of. It wasn't that great, so they never really mentioned it officially, that the NDK was supported from Gradle. So some people were using it, some weren't, so it never has been official, and recently it has even been deprecated for a better model. But yeah, first. So in December 2014, Eclipse ADT, which was supporting the NDK as well as Eclipse was supporting Android development, was no longer in development. So there was no official IDE if you really wanted to use the NDK. And in May 2015, so last Google I/O, they announced finally a full C and C++ support inside Android Studio. So as soon as they announced it, of course, I wanted to try it. I knew many people wanted to try it, but we all had to wait for July to be able to get our hands on it. And even then, it's quite beta, and even right now, it's still quite beta and experimental. But the good thing is, even if it's beta and experimental, it's still better than 2013. And it's still better, in my view, much, much better than Eclipse. So it's not because it's written experimental and beta that you should be afraid of using it right now. Maybe I should have talked about it during the early slides, but why people are using the NDK is maybe a good question to ask. There are many reasons. One is reusing code across platforms, because you can compile C++ to iOS, to Windows, to Android, so you can compile the exact same code. Sometimes you have really nice libraries, such as OpenCV and others, or OpenSL, that are only available or working better in their C++ version. And sometimes you just have to, because you need to use that code, which is C and C++. And when you're not familiar with NDK, sometimes it can be really painful to integrate into a project. So let's see how it's working these days. So I recorded a short video, but if you can't see it, I'll do it again with my IDE. So right now, with the full editing inside Android Studio, you can declare any method as native, and bam, auto-completion to create automatically a functions onto the C and C++ side with a proper header, proper prototype, and you can start coding inside it. And it will be put inside src main JNI. And it will be automatically compiled into a .so file and automatically integrated inside your APK. So everything is quite automated. It's really nice to have this support inside the IDE. You can see so you can see it's a good summary of how the NDK is working. So bottom left, you've got your Java source with string from JNI that has been declared native. Inside your build.gradle, let me zoom a bit. Inside your build.gradle, you have an android.ndk block. Inside you have a module name. It will be the name of a generated .so file. You have LD libs, which is the list of system libs your NDK module depends on, and STL, which is the C++ runtime your app wants to depend on too. And at the top, you have your C and C++ or C++ implementation. Here it's in C, which is the implementation of string from JNI. Here it was not taking any arguments and returning a string. Here, hello from JNI. So that's the most simple example you can find on the SDK. And if you look at your project, you have your Java sources, that's the usual spot. And you have a JNI folder. Inside, you've got a source. And that's it. Everything is automated. And since it's all beta and experimental and so on, you can also see the nice disclaimer that will be always there when you develop using the NDK. It's experimental. But you can do more than just auto-completion and C++ code editing with some nice refactoring. You have really good support for debug now. So it's with an example. So all these two previous examples were using Gradle experimental plugin. I'll talk more about this. You can see your standard configuration. Module name is tpot native activity for this sample. I'll describe more about Gradle after. So here it was a bit more complex project. It's one that uses the native activity. So the activity and extra is created by the system, and you have an Android main inside your .so file. So you see auto-completion is working well. All the headers are found. And you can even set breakpoints, like usual debugging. If you see it, I don't think you see it, but at the top of the IDE, the build configuration is set on app native. So you need to switch your target to app native to allow debugging, and then you can choose a target and launch debug. If you see where I've set my breakpoint here, I set it inside Android main, which is during the initialization phase of the NDK module. So if you remember how debugging was working before, it was really hard to make it work during the initialization of the libraries. Really hard. Now it's working well. And you have full debugging based on LLDB. It's quite fast. And like in Java, you get the state of all the variables, and you can do step by step. And it just works. It was very long awaited for NDK developers, because even back at Eclipse times, it was almost impossible to reach this performance of NDK debugging. So even in the code, you can see the state of variables, exactly like on the Java side. And then you can resume the execution, and here's the tpot sample. Now it's all nice, but yeah, I've said it's experimental, it's alpha, it's kind of not really finished yet. So how to get this right now, because you need it, you have your NDK code and you have to deal with it, and Eclipse is maybe not a solution anymore for your project. So there are various solutions, so right now there is the Gradle stable plugin, so the usual Gradle plugin, everyone's using it inside Android Studio, that's a default one. The NDK support from 2013 is simply not an option anymore, it's just deprecated. It was never meant to be used like it was used, it was almost a hidden feature. On the official page of Android Studio, it was explicitly written, we don't support the NDK. But you can still use the Gradle stable plugin and do your own task to call NDK builds from the NDK and to generate your lib, and then you use Gradle only to integrate your data files inside your APK. But the best now is to use the Gradle experimental plugin, because you get the full C and C++ code editing and debugging. Sometimes the NDK integration inside Gradle isn't enough, and you need to fall back to usual NDK builds and make files. It's especially when you need to integrate with third-party libraries like precompiled .so files or .a files that your NDK module depends on. In this case, the NDK integration in Gradle isn't ready. You can't use it yet, so then you have to fall back to using a task for NDK build, but you'll lose debugging. But let's go through each of these solutions more in details. So the first one, do like in 2013, use the support that was already there, so just an NDK block, module name, some configurations. I will not talk too much about it. The main flow of this option is that when you use the NDK and you compile a .so file, you compile it against a platform version. Like on your Java, you have min SDK, target SDK, and even max SDK. But when you compile NDK binary, you have just app platform. And the app platform should be the exact same than your min SDK version or lower, because the app platform defines the version, the minimal version your NDK module will be able to run on. It's like your min SDK version. But it's how they did it in this plugin is they take the compile SDK version from your Java, which is always the highest you can use usually. So in many cases, going with the deprecated NDK support can lead your code to just crash at runtime on devices under Lollipop. So you'll get like rand method is undefined, declared, like big native crashes. So yeah, really don't use it. It's deprecated anyway, and we've got much better now. Even if it's written experimental on it, it's better. Then the other solution is to use still the Gradle stable you are using. It's stable, so it's quite fine. You can use your makefiles and NDK-bles, which allows you to integrate with third-party libraries. So it's really the most configurable solution. And the makefiles and NDK-ble solution has been there since the early days of the NDK. So a lot of code is already using it. So it avoids you to having to migrate to build the Gradle with specific NDK configuration. Also, if you need to split your APKs and to have one APK per CPU architecture, for example, to save on space, you want to have an ARM APK, an x86 APK, a 64-bit APK, and so on. You can easily tune the version code from your build.gradle file. But the C and C++ code editing in Android Studio, if you're using the Gradle stable plugin, it's kind of working, but you'll miss some headers. You can't, if you're integrating with third-party libraries, you can't reference their headers if they are in C++. So it's not 100% perfect. And of course, you don't get debugging. Then, if you switch to the Gradle experimental plugin, you have the full code editing debugging I've demonstrated earlier with the small videos, but it's experimental. But honestly, it's not that bad. It's much better than the deprecated one. But you can't generate split APKs, so one APK per CPU architecture, for example, with proper version codes, because you need to give different version codes for each of these APKs, and it doesn't support it right now. I hope it will get fixed. One thing you can do, actually, is to mix use of Gradle experimental and Gradle stable plugin. So you can have your app module that is using the Gradle stable plugin and your lib module that is using the Gradle experimental plugin. So this way you can define your APKs and version codes as usual with your app module, which is using the Gradle stable, and have your full-blown Gradle experimental NDK plugin as a lib. But you still lose debugging if you do that, but you have a full editing support, and it's working very well. So yeah, I said this before, but the support for native dependencies, so if you want to use precompiled version of OpenCV from your app, is not complete. One last option you can also do is to use the Gradle experimental plugin and do manual calls to NDK build, so to be able to integrate pre-built binaries like precompiled version of OpenCV and so on. So you get full code editing because you can properly define all the headers still from the NDK module. You have a full support with the makefiles. It's still experimental. And you can't directly generate split APKs, but you can use Gradle stable for your app module, so in fact you can. So the two good solutions are these two. So use the Gradle experimental for your lib module, and either use the built-in NDK build part, or do it yourself. So we'll go through the Android experimental version. And for the earlier versions that were running on Gradle stable plugin, I will not go through these on the slides, but you can read my article. The resources will also be given at the end. I've written a full article on this. So, Gradle experimental. So Gradle experimental, you should define it inside your build.gradle. So it's instead of just Gradle, I think 1.3 or 1.4 now, you use Gradle experimental, and the last one is 0.3.alpha7. You can keep the former one too if you want to mix use of stable and the normal plugin, and the experimental plugin. To switch to the Gradle experimental plugin, sorry, you also need to switch at least to Gradle 2.6. Then the DSL is changing, so you have to migrate your build.gradle file to comply with a new language, not new language, but new way to define your modules and so on. So instead of com.android.application inside your build.gradle, you use com.android.model.application. So instead of having your first block as Android, it will be model. And then you can declare some blocks. And another change through the build.gradle file is instead of declaring, for example, target SDK version 23, it will be target SDK version equals 23 and so on. You have to use equals instead of methods that you used before. But yeah, let's look at real example. Yep, so here is a usual build.gradle file using the Gradle stable plugin, so com.android application. Com.android application, an Android block, and methods with inputs, a default config with version code and so on, and an NDK-a block inside default config. New version. You have model that surrounds all the other blocks. You still have an Android block and a default config, but look at the .with keyword here, and all the equals. And also small changes, because it would be too simple otherwise. Min SDK version is .api level, whereas before it was min SDK version. So these are, yeah, a list of small changes, but it's easy to go through these. And yeah, with a deprecated module, you could declare the NDK this way, so module name, ld-libs, stl. It's quite the same now, but it's android.ndk, so it goes directly under the Android block. And you can have also CPP flags, which are really important. So here is how you can configure from your build.gradle file for the NDK. So most important ones are module name and platform version. Platform version, it will define which version of Android you are compiling your sources against. So define it yourself the same as your min SDK version. Then you can choose toolchains, C flags, LD flags, AB filters if you want to generate only for specific architectures, and set it debuggable or not. By default, for debug builds, it's set to true. So that's a good thing. Since it's all experimental, alpha and so on, the model can still change a bit, and they are looking to integrate new things. So maybe one day we'll have CPP defines or C defines or include directories. But for include directories, so to define locations for new headers, you can already declare this using CPP flags. So I think I got some snippets. Yep, here you can see how you can use CPP flags to declare new locations with headers. So Android Studio will be able to resolve the inclusion of headers. So here it's from the teapot sample. I've shown the debug through. So you see module name, it's teapot native activity, platform version 17, because I want it to run on 17 and onwards. And in CPP flags, here I define the path to the include directory I want. So through these CPP flags, you define where your includes, not where the sources are. All the sources are automatically compiled if they are under the GNI folder anyway. But if you want to add sources that are not under the GNI folder, you can manually add these. So through android.sources, main.gni source, and you can add a directory here. And everything under this will be compiled. There is some really experimental solution to also have dependencies between modules. So like in regular Gradle project, you can have dependency between lib1 and lib2. And this is the way that it may work with the latest versions. But it's really experimental right now. It's a bit flaky. Now, you can get this snippet later, but it describes how you can use, instead of using the built-in NDK build call, you can use the make files and call NDK build yourself. So you can define the GNI sources to be somewhere you don't have any sources, so they will not be compiled. You can define the GNI libs, so the folder from which the .so files will be integrated into your APK, to be src main libs, because that's where the NDK build script will generate your libs by default. And then you can declare a small task to call NDK build from your source directory. Then we're almost out of time, and I know it's quite a complex topic. Everyone got a specific case. So for your questions now. Yep. Yeah, I think my microphone is coming.
Okay.
Hello. I'd like to ask a question. First one is about how do you manage these experimental and stable changes in Gradle file? Do you have two Gradle build files, or with version control systems you have separate branches, or you're using android.mk file for everything?
So here's an example of one of my projects. So you can see in the main build.gradle, I've declared in the dependencies the two plugins, so the experimental one and the stable one, and both in their latest versions, because if you do overmix, maybe it will not be compatible. And then I've got my app module. And in my app module, so I'm using the regular stable plugin. It's quite common. And then I can declare APK splits, a task for version code. It's usual and it's working well. And then I've got my lib module. And in this one, that's the lib module that contains the NDK code. And in this one, I'm using the Gradle experimental plugin. I still declare a block like if I wanted to configure it with a built-in NDK build call. So with references to my pre-builds and so on, because I'm using an already built library. So then I declare that I don't want to compile the sources, and I want to integrate the builds from libs. And then I've got a slightly bigger task for NDK build because I want to be able to generate debug one, but that's not a problem. But in any case, now if you look in src main GNI, where is my source? All the completion is working, even the inclusion of my external library is working. And I've got all the completion. So that's one of my use cases. If I didn't need to rely on an external library, I wouldn't keep the NDK build call, so I could still do debugging, because with this configuration, I can't do debug from Android Studio. In that case, if I really need to debug, I just comment in my file, in my build.gradle file, I just comment the task and reset this to get JNI. And yeah, I need to tune it a bit so it's working with fully with a current module. So it's not a perfect solution. Actually, there is no perfect solution today if you need to require external libraries.
Thank you. And another question is about different platforms, supporting different platforms. It's a good practice to build separate APKs for different platforms in order to just reduce their sizes. For example, if you rely on an external library like SQL Cipher to encrypt database, so it has like for MIPS, x86 and ARM platforms built, and can I merge just for example, x86 and ARM in one APK and MIPS into second one? Because as I know, there's not that much MIPS devices. That's it.
Yeah, I think the best way to do this is to use the APK splits. So that's, let me zoom in. That's a feature from Gradle, Android plugin, if you're using the stable version. So you can define splits. And you can do splits on densities, also to reduce weight, and ABIs, so CPU architectures. You enable it. By default, it will generate one APK for all the different architecture, one per architecture. So I don't want to do this, so I reset it. And then I choose which one I want to include. And also, I define that I want to do a universal APK, so an additional APK that contains everything. So with this configuration, I get an x86 APK, a 64-bit APK, an ARM-v7 APK, and another APK that contains everything, including MIPS. So that's the solution. And then I don't have any new target or flavor when I do this. All these APKs are generated at the same time, because that's only the zip and signing part that is duplicated. So it doesn't add too much to your release builds. Another way is to use flavors, so you can declare a new flavor and set an ABI filter inside each flavor. So you can do, for example, a 32-bit flavor with ABI filters, x86, ARM ABI v7, and so on, and a 64-bit flavor with another ABI filter.
Okay, and probably last question, because we didn't have enough time, and I think on lunch you can ask other questions.
Thank you for the speech. Actually, I'm interested in, do you know, can we use LLVM assembly within the NDK somehow?
Yeah, absolutely. You can define which toolchain you want to use directly. Let me just find the configuration page. So yeah, in toolchain, you can choose to use Clang.
Actually, I'm not talking the C-lang or something. I'm talking about the LLVM assembly language. Actually, as we know, using the LLVM assembly, we can build actually the lib after that for ARM or x86, you know, like, and we can have the one code for different platforms. And can we integrate the LLVM assembly right now within the NDK?
So there is nothing directly inside the NDK to help you for this, but since I think, I'm sure you can do this, but yeah, I need to look how. Yeah, I'm sure someone, at least one person tried to do this. Okay. Yeah, need to check.
Thanks.
Welcome.
Okay, thanks Xavier. Right guys?
Thank
Thanks
you.
Xavier.